For a while now, I've been using this formula that tells us that the Legendre symbol a over p, some odd prime, is a to the power p minus 1 over 2, mod p of course. So let's prove why this works. Consider some primitive root g mod p, and this just means that g to the power p minus 1 is 1 and g to any smaller power isn't 1, meaning that g can sort of generate our whole units group just by taking successive powers. We can recognize that g raised to some power I over p is just going to be equal to negative 1 to the power I. If I is some even number, then g to the I is clearly a square, therefore negative 1 to the I will be 1. And if I is some odd number, that means that it's not a perfect square, and therefore negative 1 to the I will be odd. And you may be thinking, well, a could be congruent to g to the I, but what if I found some other primitive root f such that it's an even power to get a? But remember, f is just some power of g, so if f raised to some even power gets us a, g to some even power gets us a as well. So if the only way to generate a is by taking g to an odd power, it doesn't matter which primitive root we used, it means that a can't be a quadratic residue. So with that said, let's take a to be some unit mod p, and then take a to be equal to g when we raise it to some power I. Let's let h equal to g to the power p minus 1 over 2, which means that h squared must be congruent to 1 by definition. This means that h must be congruent to plus or minus 1 mod p. That's because x squared is congruent to 1 mod p has at most 2 solutions, and 1 and negative 1 are both solutions, therefore there can't be any more. But recall that h was defined to be g to the power p minus 1. P minus 1 is the smallest power I can raise g to get 1 back. Therefore, h must be congruent to just negative 1. So now let's look at a to the power p minus 1 over 2. We know that this is the same as raising g to the power I to the power p minus 1 over 2. And by the laws of exponents, we can just switch the order to get g to the power p minus 1 over 2 raised to the power I. Now g to the power p minus 1 over 2 we defined to be h, and we showed that h must be negative 1, meaning we get negative 1 to the power I. But as we just proved, negative 1 to the power I is equivalent to g to the power I over p. Therefore, we've shown that the Legendre symbol a over p will be congruent to a to the power p minus 1 over 2, mod p. And so that's where this lovely formula comes from. Thanks so much for watching and have a nice day.